is getting processed. So let me share the PPT with you.
Okay, okay.
Okay, sir. So just let me know if it is visible.
It's visible, sir.
Okay, sir. Thank you. This is very much interesting, and this is very much related topic. We have done it in data structure, data algorithm, and everything. So many questions can be asked, many things can be discussed. Even I could ask many things if I won't able to answer your queries. So let's have start. I mean, at least so that we can have a very proper discussion over it. So let me make it full screen. So let's start with the graph database. I mean, what it actually is and how it is very much working in case of what we called in big data analytics. Fine. So the PPT is visible to you, sir? Is it, or it is not? Fine. So we have to start with graph database. So what it actually is, when we are talking about graph database, so graph database is a database that uses, I mean, graph architecture for semantic inquiry. Nothing new in it. It will use a graph architecture for semantic inquiry with nodes, with edges. So every node and edges and the properties to represent the stored data will act as a record pointer. So what it is, as a record pointer, what it is doing basically, it collects the thing and it is having kind of annotated things. Annotated means it is having the meaning for itself, but it is having some additional meaning for that particular text, that particular thing. So graph database include number of objects, as you can see. So the object known as vertices and the relationship between the vertices are represented in form of edges, which is connected to vertices and something like that. So some typical example in which we can make link analysis using graph database are Twitter, Facebook, LinkedIn, and one which is not in slide here is you can say um, it is I guess Google Map. Fine. So Google Map is a very good example of graph analytics. Fine, we should consider it. So apart from that, Twitter is there. Apart from that, sitemap path, wherever it is used, like I am clicking on your picture and I'm just clicking it on your name or your photo. So it is act as some vertices or some record pointer, which will take me onto the detailed diagram or detailed structure or detailed information about you. Like it will take me to your homepage and it will get all the information I need to have from your homepage, whether it is from LinkedIn, whether it is from Twitter, whether it is from Facebook. So it is basically that sitemap path, which is doing the, all these things. Apart from that, when we are talking about Google Map, it is totally based on graph, like shortest path first, like Kruskal algorithm, that Prim's algorithm, that like most efficient way, like shortest path first. So there are many DFS, BFS. So in big data analytics, in this context, they are using it for better analysis. Fine. To get the data from this kind of record pointer and to analyze it better. So in this manner, they will get a very authentic data. That's the whole thing is. So apart from that, if we are talking about nodes and relationship, we all know that it is working as a record pointer, and it can be entity like we give the name to our tables in our relational databases. And what relationship it is? So it is an edge which connects two edges and represent the relationship between two connected nodes. Getting my point? Two connected nodes. So we can have those kind of things from there. So to start it with, in context of big data analytics, I'll let you know that how it is done in big data analytics, how algorithm is getting done in big data analytics. So we will see it one by one. So first of all, we will go through with the types of graph databases. Fine. So databases based on relational storage. Uh, triple store in a graph, in a bracket it is written. So example of graphs come under the category under this, the graph database is hyperlink graph. What I have just told you, that sitemap path, that if it is hyperlinked, you will click it there and you will get on that route. So it will get you routed through those, and it will routed you to the destination. That's my point is. Fine. So example of graphs come under the category of this hyperlink graph. So databases based on the native storage, graph databases, big data, something like that. Fine. So let me explain it to you in a very better way. What we are going to do now. So first of all, my question to you, just write it down, and you can get back to me with your questions also. You have asked many, now it's my turn. So what is graph analytics in big data? The first question which we will have to know, because we are going through with graph databases and everything. So what is graph analytics in big data? So graph analytics is an alternative to the traditional data warehouse model, what I have explained in the previous session also. So it is basically a model or a framework for absorbing both structured and unstructured data from various sources. So what basically we are doing, we are collecting the data from multiple sources, and to enable those analysts to probe the data in an undirected manner. So just relate to it that we were having undirected and directed graph. So we have taken the concept from there, and we are just trying to get it clear that how we will take that data and how undirected and directed concept will work over here. Fine. So basically, if types of graph database we are coming into, a graph database is defined as a specialized single purpose platform. Fine. So for creating and manipulating graphs, we need this graph database. So graph analytics, basically, if we are studying it or we are discussing it, so we are discussing it in context of big data only. So if we are discussing it in context of big data only, it is a single purpose platform for sure for creating and manipulating graphs. So graph analytics is another commonly used term. Fine, and it refers specifically to the process of analyzing data in a graph format using data points as a node. That's I have already explained to you, and relationships and edges. So these are basically act as a record pointer, which tends you to take to that particular destination file, which we have already been discussed in source to sink, source to destination, when we are discussing streaming. Fine. So is big data and data analytics same? Uh, Huma ma'am, I guess I remember the name. She has asked me. So big data refers to any large and complex collection of data. That's what I have explained. And data analytics is the process of, dredging information or retrieving the meaningful information out of data. Fine. So these are the things which we need to consider of. Now, what exactly is data analytics? If we are into the graph, we should know this. What exactly the data analytics is. So if there is any kind of answer, we can have a discussion over this in a, letter phase. So now I am trying to get that role of graph database in big data analytics. So the first point is, as you can see it over here, the first point is we require the graph database. Fine. Why we are requiring this? Just to organize the messy and complicated data points according to relationships. So what makes these relationships? Those edges and those nodes. Those edges and those nodes are basically our record pointer. Getting my point? So those record pointer will take you to the concept of organizing the complicated data points, because these are the basic forms on the basis of which we have to organize this. Fine. So the second thing can be the graph analytics for big data is an alternative to the traditional data warehouse model as framework for absorbing both structure. This thing I have already been explained to you. So apart from that, if you need to discuss that, we are basically working on relationships. So now the question is, what is graph analytics? Fine. So graph analytics are required to analyze the graph. Fine. Graph analytics are required to analyze the graph. So basically what we are doing over here, um, we are basically analyzing graph. So these things should be clear enough. That's why we are using graph. That's why we are into graph. Graph is a very much classical mathematical approach. We all know. Fine. But what if we are implementing it in big data? What if we are getting the postulates, if we are getting the pros part of the graph in the big data? So for getting those things, graph database is needed. For getting those things, graph is needed. So while node present in different entities of the system, again we are into node only, then the edges represent the relationship between them. That's what I try to convey to you. So with the help of those record pointer, it is representing the relationship between the nodes, and nodes is having all the data we need to access. So we are supposed to filter those data which is not needed, and we are supposed to get those data which is needed out of it. So we are into again into very basic pre-processing sampling phase. Fine. So graph analytics used to model the pairwise correlation. This is very important. What is pairwise correlation? So pairwise correlation between people and object in the system. Fine. So the process of examining data set, what pairwise correlation, you will able to understand now. When we are, going through with the concept of data analytics, it is basically the process of examining data sets to draw conclusion about the information they contain. So on the basis of those information, there should be some correlation can be established. So those are called pairwise relationships. So data analytic technique, basically what it is doing over here. So data analytic technique enable you to take raw data and uncover pattern to retrieve valuable insight from it. Getting my point? So it basically take the raw data. Raw data has been taken, first step. Second step, it will uncover, or it will predict some pattern to extract well or to retrieve the valuable information or valuable insights from it. This is, you can make it as simple as that, just like data mining. Nothing else we need to add or something like that. Fine. So apart from that, if we are done with the graph analytics, so that's why we are trying to merge that what exactly data analytics is and how data analytics is a hybrid or combined with graph analytics. Fine. So that is what I was trying to do. So if it is clear, it's okay for me. So let's move to the second part, that how to uncover those patterns. What is difference between data and big data? If we are doing graph analytics, we must know that what is the difference between data and big data. just only the volume of data which will decide this, the definition differentiation which will decide. No, not actually. The term data analytics, what I have told you, to collect the raw data and to get information what they are containing, or to get the conclusion or to draw the conclusion. Similarly, any definition of bit circular, that big data is still a data of course. Data is a set of qualitative and quantitative variables. Getting my point? A simple data is a qualitative and quantitative variables. So it can be structured or it can be unstructured. So machine readable or not, digital analog or not, personal or not. So big data, not just more data. That is for sure. Big data means it is quantitative or qualitative. It is in bulk or not. It is unstructured or structured. It is machine readable or human readable. It is personal or not. Fine. So we cannot say that big data is just more amount of data is big data. Big data is a technology which will tend you to take some decision, which will tend you to take some information out of it. Fine. So I hope this slide is okay to you. So now what it is saying, the strength of the relationship between determine how the nodes communicate with each other. So this thing we have done in data transmission also. Fine. So this is not a new point to us. That's why I have said that this is a very important point, that relationship between how the nodes are communicate. So how nodes will communicate with each other? So the nodes will communicate, and what is the importance that they will communicate with each other? Something like that. So based on the context of analysis, we can do that this node is connected with each other. This node is connected with hyperlink. This node is connected like sitemap path. So this kind of thing. Fine. How to analyze a graph now? How you will analyze the graph? Suppose you have to analyze the graph, then how you will do it? So first of all, we need to, let's move to the slide. So there are different ways, different analysis done using graph. So when we are performing analysis of graph, fine, we have to do these things. So these are point wise. First of all is analytic technique, second one is path analysis, third one is connectivity analysis, fourth one is community analysis, then there is central analysis, centrality analysis, then there is subgraph analysis. So there are at least 4 analysis done using graph. So they include these all. So at least primarily subgraph and centrality comes under the connectivity and community analysis only. That's why they have considered primarily 4, but although these can be classified into 6 also. Fine. So when you, how to, if somebody will ask you that how to analyze a graph, then the thing is, first of all, you have to review your data. It is more accurate if you are saying that to analyze or to review the raw data you are having. Fine. So to review a raw data you are having, then what you have to do, you have to calculate the average of different trials. Fine. You have to calculate the average of different trials you are doing experiment on, if they are appropriate enough. These are some assumptions you have to make. So you have to make sure that clearly label all the tables and all the graphs in a very accurate manner, so that the result should not be varied. Fine. So if we have to do this accurately, we have to place our independent variable on the x-axis on our graph and the dependent variable on y-axis of our graph. Easy. That's we have been doing since we have done the data structure and everything. So nothing new in it. Fine. So everything is there in the slide only. So let me doing the thing for you. Let me do. So if we are doing some accuracy part, these things are very important. that path analysis and the connectivity analysis. Community and centrality is a different thing. Analytic is the primary part, so it is need to be done in any cases. Fine. Community connectivity is not very much different, but there are some cases which we will go, if we will go minutely, we will see that uh, it should be differentiate enough. Fine. So what I'm trying to say, uh, if this slide has been done, we can see that graph structured data is everywhere. It's fine. So if we are talking about social network, so just have a look over it. If we are talking about social network, so what is getting done? That vertices, users, post image. I have just explained it to you via sitemap path. Getting my point? So if we are having, or if we have to explain this, the vertices, user and post images, as you can see it over here. Let me highlight it so that it is much more explainable to you. So this is the vertices we are having. Post and images will also represent the vertices. What edges will represent now? So social relationship like directed, then Twitter will be there, which will like uh, edges. Undirected, then Facebook will be there. It is also age like based things. So likes, dislikes, everything. So how likes and dislikes are getting done, I have already been told you that how it is getting done. So this is the basic example of graph, that how graph is getting processed. Fine to you? If there is any question, just write it down. We will discuss it in the last. So actual social graph. Fine. So we have taken it from internet. So this is actual social graph. So graph analytics, graph analytics is actually based on spot fraud. Fine. Or criminal or unlawful actions such as money laundering and payment to the sanctioned entities. Fine. So in order to detect those criminals, analysts use data of social media, texting, phone calls, emails to create graph that shows how these data are related to the criminals and how these data are related to the criminal records. So these all are record pointer. Fine. So my point is ki, with that graph, government agency can identify threats from non-obvious pattern of relationship. So this is non-obvious pattern of relationship for sure. So financial transaction from the graph can be analyzed for compliance reason. For example, bank need to ensure that their customer are not in a way connected to sanctioned entities. Right or wrong? Loan decision can be made using social and financial network. Right or wrong? Getting my point? So these kind of things can be done in this kind of scenario. So national security, when there is a concern about national security through controversial graph analytics is being used by National Intelligence Agency also. Fine, it is such efficient. Why it is using? Just to go through with criminal data and to use it. Fine. So this is what we are having, that BAPE graph. So vertices of BAPE pages. Fine. Edges link directed. Generated content, click streams. So these are the streams of data. You cannot even analyze it. So these are the wave graphs. Fine. So communication activity we are doing over here. So communication activity of both suspected and non-suspected individual or two-class problem are collected and analyzed to identify non-obvious relationship and identify potential crimes, basically. Fine. So we are basically doing classification and prediction, nothing else. We are doing that only. So this is wave graph. We are having a little bit much more clear picture to you of the same thing. So you must have heard about supply chain management. So it is very much obvious in nowadays. So what it is doing here, so graph analytics and algorithms such as shortest path, I have mentioned, partitioning are, partitioning of the graph are the tools to optimize routes in the airlines, transportation network, fine, and supply chain network. So it will also provide utility optimization. Companies that provides utilities such as water, sewage services, and electricity, etc., etc. Natural gas is also LPG. So they can have, they can leverage graph analysis to build the most optimal utility distribution network. So again, we are doing the big data analytics in a context of graph analytics. That is why it is very much helpful and it is doing a great work. So you can see it over here, the semantic network. So organized knowledge is the first criteria, and we have taken it from DBpedia. Then there is a vertices called subject, called object. Then there is edges, that predicates. So example, Google knowledge graph. Fine. So even Google Map and how to travel, how to select milestone, everything is in graph analytics in itself. Fine. So recommendation engine like marketing, and I have just told you about utility optimization. Fine. So if we are talking about marketing, that social network analysis. Fine. If we are doing social network analysis, then what we have to do? We have to again organize the knowledge, isn't it? Fine. So social media networks such as Instagram, Spotify, LinkedIn, I have just told you, Facebook, Twitter are, they are relationship and connection driven application, isn't it? Sitemap path, I have just told you. So graph analytics helps identifying the influencers. They are help in identifying the communities in social media networks. Social network influencer marketing is an emerging trend. Getting my point? So due to that, due to the increasing number of social media network users, the in, it will increase in the number of customer with more establishment form of marketing. Getting my point? So this is one of the biggest prawn of this kind of cases. Then there could be also a recommendation engine which we can consider of. So what I have told you, that utility optimization like water, fish, whale, animal, mammal, beer, fur, vertebra, cat, they all are connected here, like edges and nodes. So this is called relationship building. This is called utility optimization. Another example for utility optimization. So let's move to the next slide. It is called transaction network. So when we are talking about transaction network, it could be compliance, it could be fraud detection. So in business, the work that networks such as telecom companies and or e-commerce marketplaces or financial institution graph analytics, it is used for fraud detection for sure. If we are talking about compliances, then financial entities are required to prevent payments to sanctioned entities, and graph analytics are used to support such payment. So there are lots of things, but we are tending to reach at the same destination. We are tending to reach at big data analytics only. So if we are talking about supply chain, you can see it over here, the graph analytics algorithm such as shortest path and partitioning algorithm. Those tools are used to optimize the routes in airline on transaction network, which we are doing here also. Fine. So basically we are doing exchange of goods, supplier and consumer services. So transaction like Bitcoin, fine, ages, exchange of currency. So these are the things we are having. So I hope I'm able to convey what I'm trying to convey to you. Fine. So if it is social network analysis, I have explained to you, but if it is recommendation engine, so you must have noticed social networking suggesting like social network suggesting like people you may know or song you may like, something like that. So these recommendations rely on collaborative filtering. Fine. So if we are doing collaborative filtering, which is method of commonly used by recommendation engine, so collaborative filtering relies on graph analytics to identify similar users or and enables personalized recommendation. So personalized recommendation is a different thing, and collaborative filtering is a different thing. So when we are talking about collaborative filtering, it relies on graph analytics basically. And why it is relying on graph analytics? Because it has to identify similar user. So technology companies that are not social network can also rely on collaborative filtering. Getting my point? So if they are relying on collaborative filtering, then such kind of thing can be easily done, that self recommendation. Fine. For example, I'm giving you an example. Like for eBay provides most relevant search result according to purchase history. With the survey, I mean, it is not a very global standard or universal constant. So now, if we are talking about graphic analytics or something like that, this can also be understood like this: that Japan, USA, and Canada is there. So I've told you that Google Map is also there to look after this. So you can see it over here. This is a transaction network and how it is getting done. So it is World Trade Residual Model. So graph analytics is how much important that you would be able to understand by this. By this. Fine. So it is not just a slide, it is a bulk of information we can have through this graphics. Fine. So once this transaction networks, networking, communication, social network has been done, then we will move to healthcare part. Fine. For now, biological network. So protein to protein interaction network. Vertices are proteins, edges are interactions. Fine. So let me clear it with this. Fine. So edges are interaction. Fine. Now, how it is getting useful, I'm trying to explain you. Fine. So the world is facing a pandemic situation, a very common example. So biological network we are talking about. So what is that pandemic situation is? That pandemic situation is COVID-19, isn't it? Different versions, different variants are there. So since the virus is known as highly infectious, so using the graph database, we can help the government, or the graph database will help the government to track the spread of the virus. That's what we are trying to do in a similar example. So a company called Vune, like something like Vune, has built an application using a new 4J. Fine. It is new 4J is a graph database itself that allows Chinese citizens to check if they came in the contact with the known carrier of the virus. Getting my point? It is very much applicable in China. So the, I mean, images which shown on the graph, it will better tell you that how these things can be analyzed and how we could get the known cases and that connected with the name. I mean, how record pointer can be connected. So how, my question is to you, that how it is different from regular analytics? My question is to you that how it is different from regular analytics? So the answer could be the regular analytics relies on statistics, right? Computer programming, operation research to uncover insights. But whenever we are jumping on graph analytics, we are using graph specific algorithm to analyze relationship, isn't it? We are doing it. We are doing so. So analyze relationship between what? Analyze relationship between entities. So whether it is clustering, whether it is partitioning, whether it is page rank, whether it is shortest path algorithm, whether it is DFS, BFS, these all are unique to graph analytics. Fine. So we are basically relying on graph database if we are connecting to the graph analytics, and which are necessary for the advanced graph analytics are more flexible than the relational database management system. So if it is more flexible than relational database management system, so RDBMS has a rigid schema. So it is difficult to add new data relation to them. However, new data relationship can be added in a flexible manner in a graph database. That is the most, flexible part. So that is very much useful for us. Getting my point? So these are the things we need to cover in this part of section. So like COVID example I have given to you, like graph database, that nodes, that relationship we have already been discussed. So what are the types of graph database basically? So example of graphs come under the type of graph database, that hyperlink graphs. We have already gone through with that. What is the role of graph database in big data analytics? It is helpful in big data architecture. Fine. Whether it is communication network also, it is helpful in data collection. It is helpful in data storage. It is helpful in data analysis module, and it is helpful in getting output and visualization part also. See how the things are connected and how the things are finished on a note where we have done our work before also. Who talks to whom graph? Illicit, legal, the same thing I have explained to you. If it is directed, if we are using email from to. So planning the big data architecture means big data architecture includes ingestion, ingesting, protecting, processing, and transformation, ETL, entity transformation, load. Again, so transforming data into file system or database structure, analytics tool and queries can run in the environment to get the intelligence from data. That's what we are trying to focus on. So which output to variety of different vehicles. The big data architecture consists of many things, like big data source layer, like data processing and storage layer, like analysis layer for analyzing the data, like consumption layer. So you must not a consumption layer you must not have heard of many times, because these are not basically used, but these are very important. This particular layer receives analysis of result and present the result. So if we are using graph database, we have to use the various graph visualization tool also. So according to our requirement, so that we view the results in proper graph format. For example, if we consider the big data architecture using Hadoop, then the whole processing will be shown as follow. Will be shown like this, like the graph we are showing to you. Just have a look over it. Recommended system or something like that. So if we are talking about Hadoop is an open source, and several vendors and large cloud provider offer a Hadoop system and support. Fine. So we are having code cluster for this, we are having loading the data, we are having data processing, we are having output and generation and querying part also. So there are lots of things. Then there is a graphical mode which is shown over here. So cat, apple, growth, fine, hat, plan. So random variables, factors, edges जो है, what edges is showing here, statistical dependencies. So this kind of thing, the data model can be trained like this, so that this will give the right answer. It could be analytic technique, it could be subgraph analysis. Fine, it could be use page rank algorithm, or contrary to popular belief that page rank is not named after the fact that algorithm ranked pages. Fine. So these kind of things we are having. So even if we are going for co-authorship thing, we can go for the graph, as you can see it over here. So common properties of graph derived from natural phenomena. So power law, degree distribution. So there are many things a graph can do. But in case of big data analytics, whether it is community structure, whether it is LinkedIn, whether it is Messenger, you can see the thing is getting done over here. So think globally and act locally. That is graph scenario is. So identifying the leaders we are having. Fine. These are the page rank. How page rank is getting worked. So the page rank algorithm, if we are talking about, so this can be classified to the various techniques. It covers algorithm like page rank is there, page rank algorithm is there, hits is there. Fine. So whenever we are talking about page rank algorithm, page rank algorithm, contrary to popular belief that page rank is not named after the fact that algorithm rank pages. So rather than it named after the Larry Page, its inventor. That's why it is page rank. So rank are not assigned to the subject domain, but a specific web pages. So according to the creators, the rank of each web page averages it about 1. That when the counter equals to 0, just like Twitter case. So it is usually depicted as integer in range of 0 to 10. So it lies between 0 to 10 by the most estimation tool, but 0 being the least ranked. Getting my point? And page rank is an algorithm that addresses the problem of linked based object ranking, LOR. So the objective of this is to assign a numerical rank or priority to each web page. So we will work with a model in which a user starts at web page and perform a random walk. So by randomly following links from the pages he or she currently in, whether it is moving from one page to other, and whether it is the things which we have discussed. So these are the things we are having. So yeah, we are having many contents for that, but due to lack of time we have to make it done here only. So we are having recommending products, also finding communities. So I'll share the PPT part also if it is needed. So apart from that, pipeline in graphs is there. When one method is in work, the second will be in pipeline. So there are many things how it is getting done. Fine. So I have taken from where we have taken the things and we have just cited it. So yeah, that's done from my side. You just tell me if you are having any question, because it is not possible to finish it off in this domain. So over to you, Doctor.
Thank you, Abhishek.
Yes, sir. Tell me. Am I audible, sir?
Yeah, you are audible, sir, Abhishek. So
Okay.
from the faculty side, any queries, you can use the chat box or unmute and you can ask the questions. The questionnaire session.
So one thing I want to convey to all the faculty members along with you. So we are open to all the research communities, and we are open to all the research collaborations regarding patents, regarding funded projects also. So you can contact me if there is any kind of interest from your side also. So we will have some good work together. Apart from that, you can most welcome to ask any question you are having. If you are having any, please go ahead.
I thought this session is very interesting and no number of questions will be there.
I would like to believe so, sir.
Yeah. Anyone from faculty side? I think this session is not much complicated, I think so, Abhishek.
Actually, it was very much related. Now we
Yeah,
all
yes,
are
yes,
faculty, so we have done this for a long time now.
yeah, yes.
So
Yes.
yeah,
That's
maybe.
why I think the questions are very less now.
Yeah, not an issue.
Yeah. Anyone? You can share now, otherwise you can wind the session then.
Yeah.
Yeah.
Done.
So okay, thank you so much, Abhishek.
Thank you so much, sir.
Really.
So any formalities left? Should we? on the camera or something like that is not
Uh,
needed now?
not needed now, Abhishek. We'll see. 1 minute, Abhishek.
Done.
No.
Fine, sir. I'll make a call to you, sir. Thank you so much. Thanks, everyone, all the respected faculties and dignitaries over here. Thanks a lot for having me.
Yeah, thank you
Thanks.
so much, Abhishek, for your
Thanks, sir. Thanks
taking a
for
long
inviting
day
me.
for you. It's very tough. I know it's not so easy because the time allocated for you is very short and at once such a good presentation. And really, we are
Thank you
happy
so much,
that
sir.
from the faculty side also, we had a good discussion session in the previous till day. We had a good session compared to yesterday.
Just
It was
share
good.
the feedback also, sir,
Yeah,
if,
sure,
if
sure,
bad
sure,
or
sure.
good.
Yeah, no, no.
Okay,
I
sir.
hope all will be good. No problem.
Yeah, I hope
So,
so.
okay.
Thank you so much,
Thank
sir.
you so much,
Thanks a lot.
Abhishek. I will call you a
Thanks a
little
lot,
bit
sir.
later. Thank you so much,
Yeah, yeah,
Abhishek.
yeah.
Thank you.
Sure,
Thank you.
sir. Please take time.
Okay.
Thanks a
Thank
lot.
you. I request the faculty members to wait in uh, meet so that I can share you the feedback link. So I request the faculty members to kindly fill the feedback form for day 2.